Welcome back to the e-learning Core 3 Fixed Income Analysis, Session 1.2. In this session, we will illustrate how to value or price a bond by discounting the bond's expected future cash flows by an appropriate discount rate. The second learning goal is to show how the bond price varied with the applied discount rate. The learning goal of this session is to understand the principles of bond valuation as well to understand how bond prices vary with interest rates. Now let's have a closer look at bond valuation. In general, to value a security, we discount its expected cash flow by the appropriate discount rate. The cash flows from a bond consist of the sum of coupon payments C until the maturity date T plus the final payment of par value at T. We assume now there is one interest rate R that is appropriate for discounting the corresponding cash flow streams. The value of the bond is then the sum of these discounted future cash flows. Moreover, it is important to note that the interest rate used to discount the cash flows is in nominal terms. This means, according to the Fisher equation, that this nominal rate equals the sum of the real interest rate plus an inflation premium to compensate for expected inflation. Moreover, since bonds are not riskless, the nominal interest rate might include an additional premium that reflects bond-specific characteristics such as default risk, liquidity risk, call risk, etc. A shortcut way to value a bond is using the well-known annuity formula, which is defined as coupon payments times the T-year annuity factor. To obtain the present value of the bond, we simply have to discount the repayment of the face value in year T by the corresponding discount factor, which is simply 1 divided by 1 plus R to the power of T, and add it to the present value of the annuity. To understand the concept of bond valuation completely, let us do an example. Suppose that the bond has a time to maturity of 10 years and the par value is $1,000. The bond pays a coupon of 8% every 6 months, which corresponds to a coupon payment of $40 per period. Moreover, assume that the 6-month interest rate in this economy is 3%. By applying the present value formula introduced on the previous slide, we can simply substitute in the corresponding numbers to get a bond value of 1,148.77. Note that the bond pays interest twice a year, which implies we have 20 periods under consideration. We can achieve the same result by using the annuity formula. Substituting in the given numbers and doing the math right, we obtain a bond valuation of $1,148.77. The next question we have to ask in the context of bond valuation is what is the sensitivity of the bond price to changes in the interest rate. For that purpose, we use an 8% coupon bond with a maturity of 30 years and plot the bond price as a function of the respective interest rate. The graph shows an inverse relationship between bond prices and the applied discount rate, meaning a lower interest rate implies a higher bond valuation. Another important observation to make is that the bond sells at par if the interest rate used to discount the bond's cash flow stream is equal to the coupon rate. An interest rate close to 0% means that the price of the bond is close to the sum of all future cash flows. Moreover, keeping everything else equal, the longer the maturity of the bond, the greater is the sensitivity of the bond price to fluctuations in the interest rate. Finally, the graph reveals the fact that increasing interest rates imply a fall in bond prices. If you buy the bond at par with 8% coupon and market rates subsequently rise, then you suffer a loss because you have tied up your money at 8%. In this table, we illustrate the fact that the interest rate sensitivity is greater for bonds with longer maturity compared to those bonds with shorter maturity. In other words, the longer the period for which your money is tied up, the greater is the loss and correspondingly the greater the drop in the bond price. To see this, simply compare two bonds with a coupon rate of 8%. where one bond has a maturity of 10 years and the other bond has a maturity of 30 years. A 2% interest rate increase implies that bond prices drop. However, the price of the 30-year bond decreases to $810.70, while the price of the 10-year bond decreases only to $875.35, which is a difference of about $65.